Yes, let's look at this question number 35 for WAEC Chemistry 2018. The empirical formula of a compound containing 0.067 mole copper and 0.066 mole oxygen is given that Cu copper is equal to 63.5, O is equal to 16.0. Options A, Cu2O, B, CuO, C, CuO2, D, Cu2O2. So now we are told to find the empirical formula as the formula that has the components in the simplest ratio. So how do we go about this? We are supposed to have that we have copper, then we have oxygen. Now, what is the number of moles of each that we have from the question? We have copper to be 0.067 moles. So 0.067 moles. Then we have oxygen to be 0.066 moles. So we have 0.67 and 0.66 moles. Now we are going to check out the mole ratio. So mole ratio is, you get it by dividing by the simplest or the smallest value in the two that you're comparing to get the ratio. So you can see that 0.66 is smaller than 0.67. So we're going to divide through by 0.67. So we have by 0.6 is the smaller one. 0.67 divided by the smaller one, which is 0.066. 0.067 over 0.066. Then here we have 0.066 all over 0.066, which is also the smaller one. So this will enable us to have a ratio. So when you divide this by this, you're going to have 1. But when you divide this by this, you're also going to have 1. It's close to 1. So we have 1:1 as the ratio. So when you have 1:1, you can only say that you now have copper and you have oxygen 1:1. So you can the ratio is 1:1. So you just have CuO as your answer. So that makes B the correct answer. That makes B the correct answer. I didn't mean you have something like 1 here and you have 2 here. So you're gonna have Cu2O. So yeah, it depends on the ratio. So, and how do you get the ratio? By writing down the number of moles and dividing through by the smaller one, so that you can have 1 on one side and another thing on the other side. But in this case, we have 1 on either sides. So we don't have to put 2 or 3 or anything. So it has to be CuO, because Cu is 1 and O is 1. So that's how you go about this. Whenever you want to calculate for empirical formula, it has to be the mole ratios. I didn't mean you're giving masses, then you're then supposed to use these very molecular masses, these atomic masses, to calculate the number of moles. But the number of moles is already given, so you don't need to use this to do this calculation. You just get the mole ratio by dividing with this smaller one in the 2 moles that you're considering. In this case, it is 0.066. So if you divide through by 0.066, you're going to be having 1 here and 1 here. So this makes this the right answer to this problem.